Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So we need to find the bitwise OR of subarrays. So given a integer array ARR, you need to return the number of distinct bitwise ORs of all non-empty subarrays of ARR. Okay, so if you know that the bitwise OR of a subarray is the bitwise of each integer in the subarray, that's very trivial. And a subarray is a contiguous sequence of non-empty elements within an array. So you are given an array and for all the possible subarrays you need to find the ORs, and you need to tell me that what is the number of distinct such bitwise ORs. Okay, so you need to find the distinct bitwise ORs, and this can be done in a brute force manner, which is very easy, but you see you need to do in O of n or O of n log n, something like that, because array dot length is 5 into 10 to the power 4. So what can be a distinct brute force manner? Okay, so what is subarray? If you see A, B, C, D, if I tell you, what are the subarrays? You can say that A is a subarray itself, B is a subarray. You can take one element and tell me that they are subarray, and then you can start taking two elements A, B, B, C, and so on. Okay, CD also. Only one is there extra, and you can take then three elements, and then it will be something like A, B, C, B, C, D. Okay, and you can take then four elements also, which will be B, C, D, and all of this A, B, C, D. Okay, I'm just writing all of them. So I hope you understand this. And if you try to iterate through all of these subarrays, definitely your order will be O of n square, because for every element you are iterating of the order of n. So O of n square, and definitely you can do something like you can OR all of them. You for this you will get one OR, for this you will get one OR. Okay, you just add everything in a set. So, okay, let's say set answer you have, and this in this answer you can do something like set dot insert each and every or element. You can just calculate and insert. Okay, and then you can just return set answer dot size. So this will be definitely a brute force manner, which I think that you will be easily able to think. Okay, there is nothing fancy in this. There is nothing, no specialty in this. This is a simple brute force approach. But how do you exactly? What should be your observation? Okay, so what should be your observation? First observation, in order to think something in the bitwise manner, and in order to think something specially. Okay, this is a very common method which everyone will think. So one thing, the first observation is that you are asked to find bitwise or. Okay, so one thing you must notice that if I am doing A or B and I am getting an answer, that answer is always greater than or equal to A, that answer is always greater than or equal to B. Okay, both A and B, that answer should be greater than or equal to. What does this mean? What does this mean? You might think that there may be many distinct subarrays, but if you are considering only one index, let's say you are considering the ith index, and let's say you want to find all subarrays ending at I, ending at I. How many extra do you think will be from all the subarrays ending at I minus 1? You see, let's say there is an integer. Okay, it is a 32-bit integer, first of all. Okay, so you see there can be you consider it as 32 switches. Okay, you consider it as 32 switches, and let's say you are given a number something like 10110001, something like this, and you are performing a bitwise OR of X with it. Okay, and the result which you will get is always greater than or equal to this. It's very easy to think. And how can you make it greater than? You can only convert a 0 to 1. You cannot convert a 1 to 0. So you can convert this 0 or this 0 to 1. So if you consider it as switches which are off and on. Okay, so there are 32 switches. Okay, some are off and some are on. You can only make a switch from off to on. Okay, you cannot make a switch which is on to off. Okay, so you have only very few possibilities. At max, at max you have only 32 ways. At max only 32 possibilities are exists. Okay, so now you consider the thing which I told you. Okay, so you consider an algorithm. Okay, so you have, let's say you store in a variable in a set. In a set, you consider all the element. Let's say I call this set previous. So I will consider all the element that ends at or of all the elements. Okay, all the subarrays or of all the subarrays that ends at I. Okay, that ends at I, and something which ends at I minus 1, and I will try to derive this I from I minus 1. So that is very simple. That is very simple. If you see something like you want to find an OR of A, B, C, D, okay, you want to find something like A or B or C or D, something like this. If you have an OR which ends at, let's say, what are the possible ORs which ends at C? Let me first find that. You will say that B or C, C, A or B or C. These are the possible ORs that ends at C. Okay, this is what number one, this is number two, number three. Now, if you want to find all possible ORs which end at D, what can you do? What can you do? First of all, you can do something like you can OR everything with D also. You can OR this element with D, you can OR this element with D, you can OR this element with D, and an extra thing which you can add is D. So these are from OR of all elements, okay, all of all subarrays uh, ending at I minus 1, ending at I minus 1th element. Okay, you have found the OR of all elements ending at the OR of all subarrays ending at the ith element. Okay, so I hope you understand this. This was, let's say this was I minus 1 and this was I. C was I minus 1. Then from the elements which are ending at C, you can easily find, you can just iterate through that set and add something which is D. So a very simple algorithm you can write, a very simple algorithm, not at all difficult to think also if you try to imagine. Okay, so you have, let's say, an set answer which consists of all the sets. Okay, which consists of all the set. You also have a set previous which consists of elements ending at I minus 1. So initially you have 0 in it. Initially you have nothing in it. Now what you can do, you can traverse through every element in the array for let's say auto X. You can traverse through every element in this array and just have a current OR set also. What do I mean by this? This is previous OR, and let's say this is current OR set also you are having. So how can you derive the current OR from the previous OR? You can go through all the elements of this previous OR. You can go through all the elements of this previous OR and do something like X or Y or X. Okay, so Y or X, and you can insert this in your current OR. Okay, you can insert this element in your current OR, and what else can you do? You can just, for the next iteration, you just set that previous OR is equals to the current OR, and in the final global answer, in this answer set you push back all the elements of the current OR. So I hope you understand. Okay, so if you did not understand, try to think what I am doing exactly. What are all the things which I am doing for this sentence? You see, for all the y, I go through all the previous elements. So as I was doing, if I minus 1 set has something like B or C, C and A or B or C, I am going through all the elements and pushing this D, and I am simply pushing this D's, pushing this X. Okay, ORing this X and uh, pushing into the current OR. Okay, I am just ORing this X and pushing into the current OR, and also I need to do something like cur or dot insert uh, Y X also, because the current element also. So in this manner, cur, or what does cur or give? You can calculate it easily. Cur or gives uh, OR of all arrays, or of all subarrays ending at I. Okay, and previous OR will give the same thing or of all the sub arrays, but it will end at I minus 1. And from this previous or, you easily understood how to calculate this current or. I guess I gave you this example also, and I also made you the told you the exact algorithm of how it will work. And every time you have an answer set in which you insert all the elements of cur, or in which you insert, and your final answer will be answer dot size. Set, as you know already, set only stores the distinct elements. Okay, it discards the elements which are not so distinct. So yeah, that is the thing, that is the exact thing. So the main thing is done. I hope you easily understood it. We can also start to code now. I hope there are no possible doubts. Okay, so the one possible doubt can be that if you are doing this for loop inside this for loop, how is it not giving a TLE? So as I told you, there can be at max 32 elements in this previous or in this current. Okay, at max 32 elements. Okay, in at any particular, like at if you consider, as I already told you, if you consider all the sub arrays ending at I, okay, and and that position you can have at most 32 bits. Okay, and I mean, if you want to insert something from the previous values, there are at most 32 changes you can do. Okay, so because the number cannot exceed the 32-bit integer, and you can only switch on some of the elements, you can only switch on some of the zeros which are existing. So I hope it made sense. I hope you made sense. And let's try to do the coding portion. Is really easy as well as short. So I will just quickly have a set. uh, what all will be the set? We have an answer set as well as we have previous or. Okay, let's consider these two sets only. And as you go through all the elements in ARR, what do? You have a set, another set which is current or. Okay, so you have a set which is current or. What you can do is that first you insert the first element. Okay, so first you insert this X, and then you go through all the elements for auto Y in the previous or. So in the previous or, you go through all the elements, and what you can do is Y dot, not Y, current or dot insert. You can insert this Y or X. Okay, Y or X. You insert the elements which are Y or X. So now you can just do something like this. Previous or will be updated to current or, and result will be answer dot size. But do remember to put everything to the answer. So you need to push this answer, all the elements of the set current, or you need to push it to the answer. Okay, so you can do it easily. So if you want to copy all the elements from one set to another, there is a way. You can just do it like this: set dot begin and current or dot end. Okay, so I hope you get it easily. I hope that was very simple to understand. So let's try to run it. You see, we have the accepted thing. Let's try to submit it and check. So see, we do have the accepted case. Our runtime is a little bit low. So for amortized time complexity, I can change this to unordered set. Okay. You can read about unordered and ordered set and unordered and ordered map. How do they work? So you get an O of 1 amortized time complexity if you used on unordered set. So if you try to run it again, I think there should be no issues, and you should get a little bit at least better runtime complexity. So let's try to run and check. It was a little bit better when I was running it. It came from 9% to 47%, but when I was running, it was something above 60%. Okay, so yeah, I hope you understood this approach, and it is not at all difficult. You cannot say that it is very difficult solution. It is not at all difficult, and it is very intuitive also. Okay, this is a pattern which you can just remember. Okay, how to just calculate all the sub arrays or in this manner. If some similar problem comes, then you will be able to do it, or you can select some ideas from this and use it into some other problems. So if you learned something new from this video, definitely like and subscribe to my channel. So that's all for this video. Thank you so much.